You probably think evolution is something that happened. Past tense. Something that took millions of years, produced you at the end of it, and then politely stopped, handing off the finished product so you could go live your life in a body that is essentially complete. That is not what is happening. Evolution never stopped. It is happening inside you right now, in this exact moment, in ways so slow and so invisible that you have never once noticed them, and it will keep happening to your children and their children long after you are gone. You are not the end point of evolution. You are a single frame in a film that has no final scene. To understand why, you first have to let go of an idea that most people carry around without examining it. The idea that evolution is something that happened to primitive humans a long time ago, and that modern humans, with our medicine and our technology, have somehow escaped it. Evolutionary biologist Jonathan Pritchard, who has spent much of his career studying recent human evolution at Stanford, has made the case repeatedly that natural selection did not slow down when humans developed agriculture or civilization. If anything, it sped up. Pritchard's research, alongside work from geneticists analyzing genome-wide data across large populations, has found evidence that selection pressure on the human genome actually increased dramatically over the last 10,000 years, coinciding almost exactly with the rise of farming, dense population centers, and dramatically different diets than anything our ancestors had eaten before. This makes sense once you think about it. Evolution is not a force that requires wilderness or hardship in any particular form. It requires only one thing: some people surviving and reproducing more successfully than others, based on differences that are at least partly genetic. Civilization did not remove that pressure. It just changed its shape entirely. Consider one of the most famous and well-documented examples of human evolution happening in what amounts to the blink of an evolutionary eye. Lactase persistence, the ability to digest milk sugar into adulthood. For nearly all of mammalian history, the enzyme that allows infants to digest their mother's milk shuts off after weaning. This is true of almost every mammal species on Earth, including, for the vast majority of human history, humans. Adult humans were lactose intolerant. That was the default ancestral condition. Then, somewhere around 7,000 to 10,000 years ago, in populations that had begun domesticating cattle, something changed. A mutation appeared that kept the lactase gene switched on into adulthood. In a world where milk was suddenly a reliable, calorie-dense food source available from domesticated animals, that mutation was enormously valuable. People who carried it could access an entire additional food category that people without it could not fully digest. Geneticist Mark Thomas at University College London, who has studied the spread of this mutation extensively, has described it as one of the strongest signals of recent positive selection ever found in the human genome. In populations with a long history of dairy farming, the mutation spread so rapidly and so completely that today the majority of people in those populations carry it. 7,000 to 10,000 years is nothing on an evolutionary timescale. It is a blink, and yet it was enough time for natural selection to rewrite, in a meaningful percentage of the human population, one of the most fundamental digestive rules that had held for the entire history of mammals before us. If evolution can do that in 10,000 years, what is it doing to you right now in ways too slow and too subtle to notice within a single human lifetime? There is another striking example. It involves altitude. Populations that have lived for many generations at extremely high elevation, in the Tibetan Plateau, in the Andes, in parts of Ethiopia, have each independently evolved distinct biological adaptations to survive in oxygen-thin air, and remarkably, that didn't all arrive at the same solution. Geneticist Cynthia Beale, who has spent decades studying high-altitude populations, found that Tibetans carry a variant of a gene called EPS1 that allows them to thrive at high altitude, without the dangerously thick blood that low-altitude visitors develop when their bodies try to compensate for thin air by overproducing red blood cells. Remarkably, genetic analysis published by researchers, including Rasmus Nielsen at UC Berkeley, traced this variant to Denisovans, an extinct hominin population that interbred with the ancestors of modern Tibetans tens of thousands of years ago. A gene inherited from a different human species entirely dormant for tens of thousands of years became enormously advantageous the moment a population needed to survive at extreme altitude, and natural selection amplified it rapidly through the Tibetan population as a result. Andean populations facing the identical challenge of high-altitude survival evolved a completely different solution. Higher blood oxygen saturation achieved through different physiological pathways. Same problem, two independent evolutionary answers arrived at separately because the two populations started with different genetic raw material and different chance mutations to work with. This is evolution actively happening, generating different solutions to the same problem in real time, within the span of human history that we have written records for. None of this is ancient history in the way you might assume. This is happening on timescales that overlap with civilization, with written language, with the pyramids. And it raises an uncomfortable question. If this is happening on these timescales, is it happening to you right now? The honest answer is yes. Though the trouble is that meaningful evolutionary change in a species with a 20 to 30 year generation time and a global population that mixes and migrates constantly is almost impossible to observe within an individual human lifespan. You will never see it happen the way you would see a plant grow. But researchers have found evidence that even in extremely recent, well-documented human populations, measurable shifts in trait frequencies are detectable. A widely discussed long-term study of a population on the island of Newfoundland found statistically detectable shifts across just a few generations in traits including age, at first childbirth, and cholesterol levels, correlating with which traits were associated with greater reproductive success in that specific population and environment. Other research groups studying large genealogical and health datasets have found similar patterns, subtle, measurable shifts in trait frequencies tracking with fertility outcomes across just a handful of generations. These are not dramatic transformations. Nobody is growing a new organ, but they are real, measurable signals that the underlying mechanism, differential reproduction based on partly heritable traits, has never actually paused. Modern medicine has changed the game considerably, and it's worth being honest about how. For most of human history, natural selection operated ruthlessly on survival to reproductive age. If you had a genetic vulnerability that would have killed you as a child, you likely never passed it on. Modern medicine has dramatically reduced that particular pressure. A person with a genetic condition that would once have been lethal in childhood can often now survive, thrive, and have children of their own. Some evolutionary biologists describe this as a genuine, measurable relaxation of selection pressure on certain traits, particularly those related to childhood mortality, in populations with access to modern healthcare. This does not mean evolution has stopped. It means one of its major historical mechanisms, childhood mortality, has weakened considerably in specific parts of the world, while other mechanisms, particularly those tied to fertility and reproductive timing, have become comparatively more influential. There is also the strange, modern wrinkle of assortative mating and cultural evolution intersecting with biological evolution in ways your ancestors never experienced. Who has children, at what age, with whom? Influenced by everything from career pressures to dating apps to economic anxiety to the increasing tendency of humans to partner with people similar to themselves in education and other traits, is a set of forces evolutionary biologists are only beginning to model rigorously. It is entirely possible, researchers suggest, that these modern social patterns are exerting their own subtle selective pressures on the human population, distinct from anything that shaped us in the deep past, and largely invisible while they're happening. This is the strange truth sitting underneath your daily life. You're not looking at a finished species when you look in the mirror. You are looking at a population mid-transition, shaped by pressures from your recent ancestors' diets, altitudes, diseases, and social structures, currently being shaped by an entirely new set of pressures that includes processed food, sedentary lifestyles, delayed childbirth, global migration, and mixing on a scale unprecedented in human history, and medical technology that has fundamentally altered which traits help you survive and reproduce. You will not see the results. Neither will your children, in any dramatic way. But somewhere down the line, some descendant of yours, thousands of years from now, will carry traits shaped in part by choices and circumstances happening in your lifetime right now. The food available to you, the climate you live in, the medicine you have access to, the way you and people like you choose partners, and time childbirth. Evolution did not build you and then step back to admire its work. It is still in the room. It has simply learned to work slowly enough and across a species large and mobile enough that you will never catch it in the act. But it is there. It has always been there. And it is not finished.